Yo, we saved the best for last in this lesson. Actually, I lied. Honestly, video 2 was the best. That f to f prime graph stuff is sick. But this is pretty cool too. This is all about approximating the instantaneous rate of change given a table of data, something that you need to be good at in virtually all calculus classes, but it's something that's hit hard in AB and BC Calc early on. So it says approximate the instantaneous rate of change of x at x equals 3 and x equals 14 using the data in the table. F of x is differentiable over all real numbers. That's important. So we're assuming that we know that this function is smooth and continuous everywhere, which means we can find the average rate of change and the instantaneous rate of change at any point in time. So how do we approximate the instantaneous rate of change? We use the slope. We use the two closest points that sandwich in or sandwich over the values that we're interested in. So first, x equals 3. So we go on the hunt. 0 to 2, x equals 3 is in between that. 2 to 5, x equals 3 is in between that. So those are the two closest x values to x equals 3 that sandwiches it. So though we could find the slope from 2 to 6, it wouldn't be as accurate as going 2 to 5. Even if the slope from 2 to 6 is closer, because we want to get as close as we can to x equals 3. So even if the number from 2 to 6 is better, doesn't matter. You want to get as close as you can to x equals 3, and 2 to 5 allows us to do that. So all we do is approximate the derivative. So essentially we're saying f prime of 3 is approximately, well, what is it? It'd be the slope. F of 5 minus f of 2 all over 5 minus 2. So what you're saying is, let's say that the curve looks something like this. I don't know what the curve looks like, by the way. But you're at the point 2, negative 5, and then you're at the point 5, 2. What you're finding is the slope of this secant line to approximate the tangent line slope. And is it the same exact slope? No, not necessarily. Most likely not. But that average rate of change slope is going to give us a good approximation of the instantaneous rate of change. So let's go ahead and fire away. So we plug in 5. Well, in the table, it's already given to us. That's 2. F of 5 is 2. The calculations are done for us. So you might be scared of tables. They actually allow for very lazy math. F of 2 is negative 5. Nice. All over 5 minus 2, which is just 3. When we simplify that, 2 minus a negative 5 is 7 over 3. All right, quick AB/BC exam tip. You may leave your answers in numerical non-simplified form. So that's not considered numerical because those are functions. This, however, all of these are numbers. This is considered a fine answer on the AB or BC exam. So just know that. You don't have to simplify numerical answers. Pretty sweet. All right, so if we're going to approximate the instantaneous rate of change at x equals 14, we're essentially approximating f prime of 14. So I write it as f prime of 14 is approximately, that would be f of, well, let's find the two numbers that sandwich 14, 11 and 15. So that would be f of 15 minus f of 11, the slope of the secant line between 11 and 15, all over 15 minus 11. And that is equal to f of 15 is 0, minus f of 11 is 3. All over 15 minus 11, which is 4. Now, I'm going to show you that totally unsimplified version of the answer. You could leave your answer like this. Again, this is non-numerical. It's not an acceptable answer. It's good work. This is an acceptable final answer on the AB or BC exams. Now, going further, if you wanted to simplify, because some of you are like, dude, Groden, simplify, please. I get negative 3 over 4. And you might have your calc teacher want you to simplify. So these are the approximations for the slopes of f of x at x equals 3 and x equals 14. They're not the exact values. We'll never know what those are, but they're good approximations. That's it. A very short video, but an important one nonetheless.